everyone, DP-700 is here and Microsoft Fabric is taking over. But why the shift from DP203? What makes Fabric the future of data engineering? In this video, our expert mentor breaks it all down. How to transition your Azure skills, master enterprise analytics, and the 3 must-know tools to connect your lakehouse. Fabric is already revolutionizing large-scale analytics. This is day 1 of DP700, so let's get started.
You know, DP700 is a fairly new course and a fairly new certification. We are coming from DP203. Microsoft is retiring the DP203 Azure Data Engineer certification. And they have now brought the Fabric Data Engineer certification. So, we as data engineers on the Azure platform have to understand why such a kind of a transition has been done by Microsoft. Why the focus has been shifted from Azure ecosystem to the Fabric software as a services ecosystem. Why do we need this transition? Can I not remain Azure oriented? Will I be happy to remain Azure oriented, or should I move and should I progress towards Fabric data engineering workloads? Why such a transition is required for us as Azure data engineers? This course is all about how you as data engineers on the Azure ecosystem, data engineer on the Azure platform, can transition your skill set, your existing skill set on the Fabric software as a services ecosystem. It is quite possible that the participants may not know anything about Fabric. You may or may not have heard about Microsoft Fabric. Microsoft Fabric was unveiled in public preview on May 23, 2023 at the Ignite conference. And then in the November of the same year, that is 2023, it became generally available. So from public preview in the May 2023 to its general availability in the same year, in the November, many projects in enterprise scale analytics have adopted Fabric, and it has gained a lot of popularity and acclaim. It has become extremely popular at an enterprise scale analytics. It has received a lot of positive feedback from enterprise customers of Microsoft that it really solves a lot of their analytical issues and problems that they encounter at a large scale enterprise-wide data analytics projects. So we have to understand as data engineers, what are those issues that data architects encounter when we deal with enterprise-wide large scale data analytics solutions, and how Fabric provides us a solution for all those issues that we encounter. Why Fabric is a future for large-scale enterprise-wide analytics. Yes, you might think that if I am talking about small and medium businesses, there is no need of Fabric. You are absolutely right. If you have this vision, if you have this thinking that Fabric is extremely expensive, Fabric is suitable for only large enterprises, it's not suitable for medium enterprises or small businesses who want data analytics at scale, you are absolutely right. Fabric is a solution for enterprise-wide analytics. It may not be economically feasible for small and medium businesses. If we are in a project, data engineering project for small and medium businesses, we may not see Fabric being used over there. So we might stick to our Azure data ecosystem, right? Azure Data Lake, Synapse Analytics, Data Factory, Stream Analytics. So we have so many discrete services in Azure. If you are familiar with the Azure ecosystem as a data engineer, we use various services over there. We use Data Lake Storage, ADLS Gen 2, right? We use Synapse Analytics. We use Stream Analytics. We even use Databricks. So there are a lot of products, discrete components, so to say, which are available in the Azure ecosystem. They are platform as a services, which are available to us, and we use them. So if you observe in a small to medium business environment, you might not find Fabric being used. But if you look at large organizations, planet scale organizations, enterprise wide analytics, Microsoft customers, such large organizations, Microsoft has received extremely positive feedback with the adoption of this product, which is Microsoft Fabric. Its production use has led to its demand. These big organizations want engineers, data scientists, data analysts, data stewards, data compliance and governance officers to all work together and collaborate within Fabric workspaces rather than in the discrete Azure ecosystem. The projects are becoming complex and also the project timelines are shrinking. The time to market any data analytics solution is decreasing. We want our data analytics solutions to be marketed as quickly as possible. So the time to market any data analytics solution is decreasing and the project complexities are increasing. And when you're talking at an enterprise scale analytics solution, you're talking about petabyte scale data, terabyte scale data growth, and you're talking about thousands and thousands of concurrent consumers of your data analytics solution. In those use cases, Fabric has been found, in the production use of Fabric, Fabric has been found to perform way better than a discrete Azure ecosystem that we are familiar with, or you may be familiar with till now. So if you are a data engineer on the Azure ecosystem, you are familiar with so many different services. And you might be wondering, hey, all of a sudden, you are now saying that there is nothing called as DP203 Azure Data Engineer. Now there is something called as Fabric Data Engineer. Why do you want to shift my focus from Azure to Fabric? What has happened? Is Azure not valuable? Is Azure not providing me what I really want to do my data engineering job? The answer is no. Azure is providing all the beautiful discrete components, so to say, various services which we are familiar with, but Fabric is a unified, end-to-end, enterprise-wide data analytics solution. It offers a single place to collaborate for all the data professionals that might be working in a very large and a complex project. As a result of which, it is time for us as Azure data engineers to understand that how we need to transition to Fabric data engineering workload. We may be required in the future projects to work in the data engineering workload inside the Fabric, not in the discrete Azure data ecosystem. We might have existing projects that might be using discrete Azure components, but in future, we might be required to use Fabric data engineering workload. So we are required to practically understand, practically learn, and also prove our credentials and our skill set through an examination and a certification that yes, we are highly skilled not only in the Azure data ecosystem, the discrete components, but we are also highly skilled and competent with a proper certification on data engineering workload on the Fabric platform. What is the outline of the course, right? So let me now show you the official outline, right? So you can see over here the official outline of DP-700. We're going to be covering all of these different modules. Course introduction is what we are going through at the moment, right? Then we will look at explore end-to-end analytics with Microsoft Fabric. What is end-to-end analytics? What do you mean by end-to-end analytics? And why do I need to do it in Fabric? Why should I do it in Fabric? That is the introduction to Fabric. Why Fabric has achieved such a great positive feedback in the production use after its general availability in November 2023. So after November 2023, a lot of positive feedback has been echoed by the people, by the companies who have used Fabric in the production environment, and now it has industrial demand. So why should I do this in Fabric? Why can't I do it in Azure data ecosystem, right? That's what we will highlight, end-to-end analytics with Fabric. Then we will start with the foundation of data engineering inside Fabric. which are lake houses. We will understand what are lake houses in Microsoft Fabric, how do we create lake houses in Microsoft Fabric, how do we leverage them for analytical needs, and how beautifully the lake houses have been designed by Microsoft, that they not only support unstructured data to be kept inside them, but even structured tables without data virtualizations, without creating external table, without degrading the performance, right? You can query the data kept in the lakehouse using your Transact SQL language. So we as data engineers, we love T-SQL, we love structured query language. There is no data professional on this planet who has not learned SQL. We all have some familiarity with a structured query language. I will be sharing you a primer, a small course, a 4-hour course, which will help you to brush up your SQL knowledge, which will help you to brush up your SQL exposure if you have forgotten a little bit of SQL. I would be sharing that. But structured query language is so popular that it is even taught in schools, right? In 11th and the 12th grade, they teach it in informatics practices courses, right? SQL has become so popular as a data language, data query language, that everyone knows it. So how do we use lake houses to query with SQL? And then obviously, lake houses should be leveraged with Spark technology. We have to do advanced transformations and ETL using Spark on the data kept inside lake houses. So then we will learn about Spark programming on top of the data that is kept inside the lake houses. And Microsoft has made it extremely simple by saying all data will be kept, structured data, right? All structured data will be kept in the open data format, and that is Delta format. Microsoft is not going to use any proprietary data format. They are not going to use any proprietary data format, okay? They're not going to use their own LDF or MDF files. They're not going to use their star.idf files in the import datasets and semantic models. Everything will be on open data format, that is Parquet Delta, Delta Parquet. Now that leads to a lot of benefits. We will see as data engineers that when you say everything would be in a single open format, that helps us to reduce data movement, that helps us to reduce data copy, which is duplication of data, and it helps us to make a single version of the truth of our data system for all data professionals. Whether you are a data engineer, whether you are a data scientist, whether you are a data analyst, all of us use same data. We don't use different data because we don't create a copy of the data. Earlier, what used to happen is that we need to create a lot of copies. We need to create a lot of data movement. We had to write various copy activity pipelines to copy the data in the workspaces of various different teams because they were using different products, right? Data scientists were using Azure Machine Learning. Data engineers were using Synapse Analytics. So all in all, they used to copy a lot. They used to move the data a lot. They used to create duplication of the data. And then a lot of inconsistencies would arise because they would transform the data, they would change the data, and there would be then discrepancies, inconsistencies, right? When you don't create many copies, when you have a single copy of the data, when you have a single vision of the data, all such problems go away. There is no need to create multiple copies of data. There is no need to move them so many times. There is no inconsistencies or multiple versions of truth, so to say. Single version of truth is there. So that is the open delta format. All structured data inside the lake houses and the warehouses will always be in the delta format. And that leads to great benefits. And that is what we will see work with Delta Lake tables in the Microsoft Fabric. Then we will also understand that what are the different ways for us to ingest the data inside our Fabric lake houses. Yes, we would require to bring the data into the lake house. We can create shortcuts. We'll understand what shortcuts are. We will learn about copy activity pipelines. We will learn about data flow generation too, right? Your Power Query data flows, which you use in your Power BI premium workspaces with enhanced compute engine. So our Power BI premium Data Flow Gen 2 with enhanced compute engine are also available in the Fabric workspaces. So that is the de facto standard of ingestion, right? Apart from it, there are programmatic methods also like Spark we can use for ingestion. But yes, you see, we will be learning about ingestion of data with data flows generation 2 in the Fabric. Today, we will hopefully complete the first two modules, right? Today, our aim today is to complete the first two modules, and later tomorrow we will complete the other two modules, right? We will look at the other two modules tomorrow. As and when we will begin our different weeks, I will keep on introducing you to the other modules. There is no sense of discussing all of them at the moment, but you can see these are all the different modules that we will cover in this month, right? So orchestrate processes and data movement, that is pipelining, the medallion architecture, bronze, silver, and gold refinement procedure, which is done using Delta Lake architecture, real-time processing inside Fabric for incremental data processing, real-time event streams, real-time data. So you see a lot of focus is there on the real-time data as well. Then we go towards data warehousing, structured data warehousing, which is a proven way for reporting. If you want to report, you need data warehouses, right? So how to do data warehousing inside Fabric, which is our primary workload as a data engineer. So we need to learn about what are data warehouses, how to load and ingest the data inside the data warehouse, how to monitor the performance of the data warehouse, and how to secure our data warehouse. Then, obviously, we will learn about deployment pipelines, CI/CD, inside the Fabric. Because in a real world project, we will always have dev, test, and production workspaces, and we would require proper pipeline procedures to migrate the assets from dev test workspaces to the production workspaces. So obviously, we will learn about CI/CD, monitor the activities inside the Fabric, secure data access in the Fabric, and then there is even a discussion on Fabric administration. Although we are not Fabric admin, we are data engineers, but having some background on Fabric administration is good. Don't worry about what we're going to do in the second week, third week, and the fourth week. But as and when we will progress, I will keep on uncovering these modules, and you will enjoy, believe me. Today, our aims and objectives are to cover the ground on Fabric introduction and getting started with lake houses in Fabric. There is one question in the chat from NN. What is Delta generally in data engineering? Although we will cover it in great detail tomorrow, but Delta is incremental processing, right? So transactions update the data, insert, update, or delete. So the state of the data change once we do a transaction. So if you have a file and you change the content of the file, I need to record what you changed in it. I need to maintain the log of what you changed in it. If I want asset properties, atomicity, consistency, isolation, and durability. So in our traditional RDBMS, in our traditional SQL Server, Oracle instances, we have transaction log, right? We have a transaction log. It records the changes that you are doing with your tables in a transaction log. And when you commit your transaction, those changes are permanently applied to your tables. So when we do it on a lake, on Parquet files, that is called as a delta table, which helps us not only to maintain the data, but also maintain the changes as we do on the data. Delta means change, right? Sir Isaac Newton, right? Delta, calculus. So Sir Isaac Newton invented calculus. So this word delta comes from there, change, the study of change, right? How things change. So that's delta. We're going to look at it. What is delta in a great detail? I will be sharing you a lot of practice to go deeper into that. One more question I will take, and then we will proceed towards introductions, and I will help you to get started with the Fabric. Does Microsoft ask companies to move from Azure ecosystem to Fabric in coming days? Will legacy Azure component support will stop? No, that will not happen. They will not stop Azure components altogether. They will always be available. The standalone Azure services will always be available. Your Azure Data Lake Generation 2, your Synapse Analytics, your Data Factory, your Databricks, they all will be available in the Azure ecosystem. But the point is, if you are looking at future projects, which are large scale projects, not small and medium businesses, I'm talking about large projects, I'm talking about petabyte scale analytics, terabyte scale data growth, and thousands of concurrent consumers of the analytical solution. That's true enterprise scale. In that case, data architects will prefer Fabric instead of going with discrete Azure components. And that is already occurring. Fabric in the production use has garnered a great amount of positive feedback. That's why Microsoft is asking now all professionals, data professionals, that if you are a data analyst, become a Fabric data analyst. If you are a data engineer, please also learn Fabric data engineering workload. Don't forget your Azure ecosystem, but also get the exposure and the practical skill set and a certification of Fabric workloads, right? Because Fabric will be the future projects. So when you're going to look 1 year, 2 year down the line, or even 6 months down the line, you will see that large scale enterprise scale analytic projects are happening on Fabric. They want you to know Fabric, right? They want you to know how do you collaborate inside Fabric workload? How do you collaborate inside Fabric, right? We will see it. It will become clear to you that yes, the future is for Fabric, right? Believe me, the future is the Fabric. That's why Microsoft moving. Microsoft saying to the professionals that we are telling you that in the future you will have requirements on Fabric. They will ask you, you go for a job interview, you go for a job requirement, job description, you will see they say Fabric is required. You need to know Fabric workload. Okay, and things will become clear to you as we go through this course, right? All your doubts will go away because you're going to see with your own eyes that yes, not only the Azure ecosystem, but also the Fabric is a great software as a services experience. Fabric isn't a part of the Azure ecosystem? Not per se. Fabric is not a part of Azure ecosystem. How do I say Fabric is not a part of ecosystem? Because Fabric is in itself a software as a service. It is in itself a software solution. It is not a platform. It's not a platform as a service. It's not your Synapse Analytics. It's not your data factory. It's not your data bricks. It's not your data lake generation 2. It's not a platform. It's a software in itself. Microsoft brands it as SaaS, software as a service. It is available in Fabric capacity on Power BI, right? Your Fabric workspaces. We'll see it. So broadly speaking, I would not like to go into too much of depth of this question because this is what we will discover all throughout the 8 sessions, that Fabric is a software as a service which encompasses discrete Azure ecosystem, right? It will encompass all of that. You will find that large scale projects should be done inside Fabric. Small scale, small and medium businesses, right? Happy to go with discrete ecosystem, but large scale, I as a data architect would prefer Fabric, and you will discover why very shortly once we start Fabric. Explore end-to-end analytics with Fabric. What is it all about? What are the learning objectives? Describe what is end-to-end analytics in Microsoft Fabric. Why do I need that? What is the need for different data teams and the data professionals, the roles, to come together in a single unified, synergized, integrated, non-disparate Fabric environment, Fabric ecosystem, rather than in a discrete environment? Why to collaborate in a unified environment? And then how to enable and use Fabric. If you really want me to learn data engineering workload on Fabric, tell me how to enable it and get started. Let's quickly discuss that, and then we will take your questions, and then we will break for 10 minutes. As I just highlighted to you, we as data engineers use different products. We use Data Factory, we use Stream Analytics, we use the Spark, Databricks, right? Databricks is Spark, Synapse Analytics, so many different products. Fabric is a software as a service which brings all of these workloads inside its unification, not as a discrete toolkit. It's not a toolkit. It's not your picnic box, right? Where you just put some plates and the forks and the spoons and various vegetables and whatever your great amount of material that you want to enjoy on picnic. It's not a picnic box. It's not a toolkit. It's a unified workspace that gives single version of truth for the entire data teams. What data engineers would give you, data scientists cannot dispute, right? So if a key performance indicator is computed by a data analyst, others cannot say, no, this is not a truth. According to us, total sales is something else. These numbers are hooked up. These numbers are not right. There might be some data cleansing issues. You might have done some issues in your ETL. You might have not cleansed the data properly. These numbers don't make sense. We're going to provide you the right report. That is inconsistency, right? Inconsistency is the biggest enemy of decision making. You cannot make decisions if someone tells you that total sales is something else than other, right? Two reports not in tandem, right? Inconsistent reports. CEOs, CFOs, all these decision makers, they cannot take any decision if the reports are discrepant and untruthful. That lowers the reliability on the reports, right? So Fabric is a single version of truth for all the data teams, whether you are a data factory workload where you will do data integration, ETL, right? Using Power Query, data flow generation 2 on the enhanced compute engine. These are called as mapping data flows and Power Query online activities in data factory. I will show you very shortly what that is. That is inside the Fabric now. We must do that inside the Fabric, okay? The data integration capability using Power Query, data flow generation 2 on enhanced compute engine inside the Fabric. Data engineering using lakes, warehouses, lake houses, Spark. That workload is now inside Fabric. We should not do it on Synapse or in Databricks. As far as recommendation is concerned, right? Going in future, Fabric will be the platform. So we're going to do it on Fabric. You want me to do data engineering workload on Fabric? No problem. A lot of benefits. You will see what the benefits are once we do practical demonstrations. Today is the day one. So I am trying to motivate and highlight the key points, but you will see from other classes, we're going to have a lot of demonstrations rather than me talking. Just stick with me for a few hours, just 1 hour, right? So data engineering workloads, your data engineering with Spark, your data transformations at scale using our ETL pipelines, right? So all of that we're going to be doing inside the Fabric workspace. We're going to take a break very shortly. Just give me 10 minutes. We're going to take the break within 10 minutes. Just give me some time. Let me just quickly complete. Yeah, we're going to be discussing what is OneLake, right? OneLake is the unified single version of truth for us. All the Fabric workspaces of our tenant keep the data in the OneLake. And all the different workloads, whether it is data science, whether it is data engineering, whether it is real-time processing, all of them see the single version of data from OneLake. We don't copy the data here and there. Single version of truth. The data system of Fabric is on the foundations of OneLake. All our lake houses or our warehouses, they all are stored inside the OneLake. We'll discuss that. And that is the single version of truth, the OneLake, right? There's no need for us to create thousands of lakes for our projects. Single lake. There is a reason to do it. We will discuss that. Data warehousing. If you want to do industry-leading SQL reports, we're going to do it in Fabric data warehouse workloads. Where did we used to do it earlier? We used to do it in dedicated SQL pools, right? If you remember, we used to use dedicated SQL pool to do it inside Synapse, right? But now we have to do it in the data warehousing workload inside the Fabric. The data science workload, Azure Machine Learning Workspace and Spark for model training and execution tracking. Where should we do it? We should do it in Fabric environment. We should leverage the Fabric to do advanced predictive analytics. That is our data science. Real-time processing using event houses and event streams for processing large volumes of data in real time. Again, we used to use a Spark structured streaming or Azure Stream Analytics. Now we have to use Fabric event houses and Fabric event streams. And not last but not the least, we have to report, visualize, create dashboards, create apps for storytelling. This is the work of data analyst. We typically don't do it as data engineer, but that is also available inside Fabric. All of these beautiful workloads are inside Fabric. It appears, there may be a question that is coming into your mind. It appears like a toolkit. Are you trying to confuse me? Are you trying to give me a toolkit that here is your toolkit and here are the different things in this toolkit? Use it from this toolkit? The answer is no. That's where the entire point is. That's where the entire point is. That Fabric is not a toolkit. Fabric is a synergized software as a service which helps us to remove data silos and improve collaboration to increase the time to market of our data analytics solution. We will see it when we do the demonstrations. You will discover that everything, whatever happens in Fabric, happens on a single version of truth. We don't move the data unnecessarily. We don't create unnecessary copies of the data. We don't duplicate the data. We always do whatever we do on the single version of truth. And that leads to success. That leads to success within various data teams, all the different data roles and data teams who are collaborating in a very large data project. Imagine the team of data scientists come to you as a team of data engineer and they say that there is some inconsistency and data quality issues in what the data you have provided. Whereas we as a data scientist team, we did some data pre-processing and our model is trained on our data, not on your data. So what does that mean? That means there is some trust and reliability issue between the teams. Why does it happen? Because we are unnecessarily creating various copies of data and we are unnecessarily doing ETL processes on different copies of data, and then eventually we have reliability and discrepancies between the data assets. Fabric aims to remove all of them. Fabric is not just a discrete toolkit, but it is really a synergized solution which aims to achieve success for all the data teams, whether you are data scientist, data engineer, data analyst, machine learning engineer, data compliance officer, all of them work in synergy on a single version of truth of the data, right? More of it will become clear once we see demonstrations. Let me now launch a browser. Just give me a second. So here we go. I will open an incognito browser. So I'm going to close all this and open the incognito mode. So how to access Fabric? I hope the screen is visible, right? So how to go to Fabric? You can simply say fabric.microsoft.com, fabric.microsoft.com. That will take you to the Fabric, fabric.microsoft.com. Alternatively, you can also say app.fabric.microsoft.com. One and the same thing, does not matter. You can say fabric.microsoft.com. And you see, it brings us to the page where it says, hey, you want to access Fabric? Please provide us your organizational email, company email. Yes, it is not available for personal accounts. You cannot access it using Gmail, Outlook, Hotmail, Live, Facebook. You cannot access it using personal accounts. You require an organizational account because this is a software as a services solution which is purchased by enterprises, companies, right? People are asking Microsoft, give us premium per user Fabric where individual users can also get Fabric. But currently, Fabric is only available for organizations. Organizations purchase Fabric for their employees. So if you are in some organization, they would have got Fabric for you. Or if you work in a Fabric project, you will get access via your organization's account, your company credentials. For the lab environment, our training coordinators will provide you a proper account to get access to the Fabric. So let me now access the Fabric with my MCT account, the trainer's account. Okay, so let me just quickly grab my email over here. So here is my corporate email given to me by Microsoft, right? So here it is. So I say submit. Here it goes. Sign into your account. And I'm going to key in my password. So here is my password. This is given to me by Microsoft, right? So I go and say sign in. And I say stay signed in. So here you see on fabric.microsoft.com or app.fabric.microsoft.com, I am successfully trying to sign up for Fabric using my corporate account given to me by Microsoft. So you see here it comes. Do you want to get Fabric free trial using this account? I say yes, please sign me in. right? See, they want me to give a business phone number. So again, I'm going to give that. This all information is given to me by the company, right? So you will have your own Fabric account. You do not need to worry. Where does this account come from? This will be your corporate account. Okay, don't worry about that. Get started. This is how we enable and access the Fabric. So thanks for signing up for Microsoft Fabric free. Get started. You might be thinking, hey, who will give us this account? The training coordinators will provide you the account. You do not need to worry. Where is the account? Where is the mobile number? You will be given the access. Don't worry on that front. So get started. And that brings me to the Fabric software as a services platform. You can see app.fabric.microsoft.com. And here we are on the wonderful Fabric software as a services platform. Let me cancel. You can take the tour if you wish, right? When you work, you can take a tour. But since I will be touring you, so I am just canceling the tour. By the way, at the time of this session, you see FabCon, that is Fabric Conference, is happening in Las Vegas. So if you want to attend that, you can. $150 are off for everyone using this code MSCUST, right? So you can attend the Fabric Conference. You will find a lot of wonderful data professionals over there. Okay, but let me now close this. As I told you, do not worry about how will you get access to Fabric. In a real world project, your company for whom you are working as a data engineer will provide you the corporate account to access Fabric. As far as this training is concerned, our training coordinator team will give you a proper account to access Fabric. Okay, don't worry on that front. Okay, in a real world, company will give you the account. The way Microsoft has given me the account here, you see, I just logged in with lodsprod.mca.onmicrosoft.com and then a password. So that's the corporate account that I'm using. Okay, you can see in front of you the Fabric software as a services platform in front of you, Fabric ecosystem. Okay, you need to enable the Fabric trial for 60 days. Otherwise, you're going to have to give your credit card, which we don't want. Okay, so I will now enable the free trial. You see, there is an option to enable the free trial. I would say give me 60-day free trial so that I can see what Fabric gives me before I really buy Fabric. How to buy Fabric, we will discuss it in Fabric administration. There is something called as Fabric capacity. That is how we can buy Fabric. Any company can buy Fabric, but we don't want to buy Fabric. We will just take a free trial, and here we go. I say, give me a free trial of Fabric. So see, trial capacity region, they are giving me a trial capacity, trial Fabric capacity in North Central US. I say, okay, please give me activate a trial capacity. You are now successfully upgraded to the Fabric, and you now have the free Fabric trial capacity. You can create and work with Fabric item types, Fabric workloads, work with these Fabric workloads for 60 days, and then eventually take a decision whether you want to do your advanced enterprise grade, enterprise scale data analytics projects on Fabric, and then subsequently buy Fabric capacity. Then we can go and buy Fabric, right? There is an option to buy Fabric. I don't want to go into that option at the moment because that's not our focus at the moment, how to buy Fabric. We will discuss that at an appropriate moment, how to buy Fabric. Here you see, I'm successfully logged in onto the Fabric software as a services platform, app.fabric.microsoft.com, with a corporate account, the corporate account which is being provided to me by Microsoft. Okay, user one hyphen something 4791 something, and then the account, and then the password, and then the business phone number. And I just enabled the 60-day free Fabric trial capacity, and now I am on the Fabric portal. So here is the Fabric landing page, the home page of Fabric. You can see welcome to Fabric, and there is something called as task flows. We'll discuss them, right? Right now, we are not focusing on task flows, but please observe on the right-hand side menu that you have an option over here which says workloads, right? It says workloads, right? Let me click on that, workloads. And that opens all the workloads that are currently available to me inside the Fabric software as a services. What do you see? You see all of these are included within the Fabric out of the box. You have data engineering, you have data factory, you have data science, you have data warehousing, you have transactional databases, you have industry solutions, you have Power BI, you have real-time intelligence. all in one product. All in one product, right? You see, data engineering, factory, science, warehousing, databases, transactional, industry solutions, Power BI, and real-time intelligence. In a real-world project, there will be separate professionals, separate teams of various data professionals who would be working on these different workloads. It is not that you have to work on all of them. Not at all. It's not possible, right? It's not possible. How can there be a single individual who can work on all of them? But yes, as far as our role is concerned, our role aligns with data engineering and the factory workloads, also the warehousing workload, also the real-time intelligence workload, and sometimes even databases. So what I try to highlight is that in our project, real world projects, you would be working on data engineering, data factory, data warehouses, databases, and real-time intelligence workloads. So we must learn these workloads. These workloads are out of the box, OOB workloads. They always come with Fabric. But your company, for whom you want to do the project, they can even add more workloads. Some of them are available over here. To test, preview, Osmos AI, Data Wrangler, Power BI Designer, Quentexa Unified, Teradata AI Unlimited. These are other workloads. Currently, obviously, we are not concerned with these preview workloads, right? Here are Fabric out of the box workloads. Fabric should be learned with breadth and then with depth. As some of our participants are saying, at the time, the job specifications and job descriptions require us to have background and practical knowledge on all of them. Absolutely right. But you cannot be an expert of all of them. You might be expert of some workloads, but not all of them. It's impossible, right? So, as I told you, we are concerned with the data engineering workload, the data factory workload, data warehousing workload, databases workload, and real-time intelligence workload. If you click on any of these workloads, for instance, let's click on data engineering workload. Let me click on that, data engineering. If I click on data engineering workload, you find they give you step-by-step learning to get started with data engineering. Create lake houses and operationalize your workflow to build, transform, and share your data estate. Don't worry about what is written over here, right? But look at this. You have samples to learn. You have over here an article, what's a lake house? You don't have to open them, right? That's my job to explain you what these things are. That's not your job, right? But they have given over here to you learning articles out of the box. You don't have to roam here and there to get learning articles. They are inside Fabric for you to get started. I will show you what these are at an appropriate moment, right? But now look at Fabric items that are under that engineering workload, if you observe. If you observe, you see that there are some item types under that workload, data engineering workload, which you have to master. And under that, we have all of these items. So if you are in a Fabric project, you are responsible for these item types because you are responsible for this workload. That's your job responsibility. What are the item types that you can see? Lakehouse, notebooks, environments, Spark job definitions, user data functions, which are in general preview at the moment, public preview at the moment. API for graph query language, which we use, as you know, in graph processing. These are the items that we expect you to be able to create and manage. Can you create and manage lakehouses? Can you create and manage notebooks? Can you create and manage environments? Can you create and manage Spark job definitions? Can you create and manage user data functions? Can you create and manage API for graph query languages? If yes, great. You can work in the data engineering workload in a large project in Fabric, enterprise-wide project. Let me go back to the workload. Look at other workloads like factory. Let me open this workload because we will be responsible for this workload as a data engineer. Let me open the factory. Look at this, wonderful, right? You see, solve complex data ingestion, transformation, and orchestration scenarios using cloud scale data movement and transformation services, right? Again, a lot of learning material is available. Amazing. Microsoft wants to make our life easy, right? They know that you are transitioning, right? So they want to make sure that you get great instructions and also learning material at your disposal. But look at the different item types that you should be able to do. Data flow Gen 2 on the enhanced compute engine, the Power Query Online. Okay, this is nothing but Power Query Online data flow. You must be an expert of this because this is our bread and butter. We have to develop data flows day in and day out for our data science teams to consume. Generic data pipelines, factory pipelines. Okay, if you can do this, the third one is really not required. Okay, because this is what you can do in factory also. Apache Airflow job. We will have a challenge exercise for you on this Apache Airflow job. Copy job mirroring. Amazing. Mirroring. Okay. What is mirroring? There are so many data sources that Microsoft provides us to mirror them. There is no need to copy the data manually. You don't need to do any kind of a change data capture. You don't need to do anything. Change data capture. System will automatically mirror it through change data capture. Amazing technology. I'm trying to introduce you, right? So we are responsible as data engineers to manage these item types in a large enterprise-wide analytical project if the project is being done on the Fabric software as a services, which most of the organizations are now opting for. A lot of learning content is also available. Let me go back to the workloads. In a similar way, you can check other like data warehouses, warehouse, notebook, mirrored. See, for data warehousing, you have to mirror your data from so many places. That's why mirroring is important. We are responsible for this. You, as a data engineer, must be able to do these item types. And that's what you will learn, right? Data flow Gen 2 is not ADLS Gen 2. No. ADLS Gen 2 is storage. Data flow is transformation pipeline. Okay. ADLS Gen 2 is data lake storage generation 2. Data flow Gen 2 is transformation pipeline. Let's not confuse the two. Okay. So here you can see data warehousing workload, which is also your responsibility. So if you say that you are a Fabric data engineer, you must be able to do these item types. And that's what you want to learn all throughout this 1 month and the upcoming months. Okay, because you will continue to do your practice. And then you have essentially real-time intelligence, event houses, event streams, activators, KQL query set, and real-time dashboard. These are the items that we want you to create as a data engineer for real-time processing. If you want to do real-time data processing for me or for any organization, we expect you to be able to create these item types. Again, you can see wonderful learning content is available for you to get started. You need not worry about that. Go back to the workload, last and the final workload, operational databases. SQL database, which is currently in preview, right? These are the 5 workloads that as a data engineer, you must be able to successfully, confidently, effectively, efficiently be able to do. If yes, you will be a Fabric analytics engineer, Fabric data engineer expert, and there will surely be a great demand going in future, right? For this, there is already the demand. That's why the certification has started on it. Okay. These workloads are what you are expected to learn. These item types are what you are expected to master through this course and through your practice and through your exercises that we will be providing you. I will be explaining to you most of these in the classroom. Some of them will be given as offline documents to you because in the classroom, everything we cannot fit in 4 hours, right? So some of them we will be giving, some of that we will provide you as the offline documents for you to go through as your handouts. Okay. So these are the workloads. Let me go back. I will take your questions very shortly. We'll come to lakehouse, warehouse, how to pick one, design decisions. We are coming to that. Don't worry on that front. Let's hold the horses. Right now, I'm just introducing Fabric to people. No one should confuse why are we here, right? We are here to learn these workloads to do in Fabric. We want to do them in Fabric, right? And these are the workloads that we have to master. These are the item types that I should be able to create in my data engineering job responsibilities. Okay, these are the workloads. Now, let's come back to the home page. Let's come back to the home page. Now, you are talking about data, right? The first question that I want to ask all of you is, what kind of data do we have in the world? In the world that we see all around us, what kind of data do we have all around us? We have tables, relational databases, transaction databases. So when you purchase something on Amazon, they record your order details, they record the customer details, they record the product details, they record the detail of your transactions in some structured tables, right? They store it in nice, clean tables, right? Orders table, customers table. Okay. But when you go and join a YouTube live, when you go to Facebook, when you go to Twitter, you don't see any tables. You see streaming video content. You find recorded video content on YouTube. You find photos on Facebook, and you find text tweets on the X. Now, earlier it was Twitter, right? That is not tables, right? So what is that? That is unstructured and semi-structured data. The images that we see on Facebook, the tweets that we see on X, right? The PDF documents that we see in CRM systems, the call data that we see, the voice, the call recordings that we see in CRM systems, sound files, video files, images, videos, backup files, what are they? They are not at all structured tables, right? I cannot store them in Oracle. I cannot store them in SQL Server. I cannot store them in MySQL. They are not tables. Where can I store them? They are unstructured and semi-structured. So if we look at the world around us, we find the data in different forms and shapes. We find the data that is nice and clean, and it is sitting in tables, nice clean tables. Rows are there, columns are there, data is nicely fitted in those rows and columns. Structured data, right? Tables, relational databases, which you see, right? SQL Server, Oracle, MySQL, PostgreSQL. These are the products that help us manage clean structured data. But we see a lot of data that is not clean, in the sense it is not structured. Images, videos, sound files, PDF files, call recordings, voice, audio, YouTube lives. What are they? They are unstructured and semi-structured. So my question is, I want to store all of that data at one place. What to do? You as a data architect, or you as a data engineer, or you as a data professional, give me a solution. That's my problem. My problem is I want to store all forms of data, whether it is tabular, whether it is images, unstructured, whether it is videos, whether it is document file, whether it is a PDF file, whether it is a backup file, whatever it may be, I want to store it in one place. Where to store it? You give me a solution for it. Where should I store it? NASA is saying store it in a data lake. Data lake. Okay.
You can store it in Cosmos.
Someone is saying store it in Cosmos database. Can I store a video in Cosmos database? Or I need to store JSON documents in Cosmos database? Can I keep a 2 GB Hollywood movie in Cosmos database? No, right?
Only storing can be like, there are various options, but depend upon like how you are going to eventually use it. The solution, there will be very limited options available. For storage, it's not an issue.
Storage. I'm simply asking, I just want to store it. That's it. I want to store it. Anything it may be, it can be a docx file, it can be an Excel file, it can be a CSV file, it can be a Parquet file, it can be a backup file, it can be a CSV file, Delta format tables. I want to store everything, whatever is there in this world, in one place.
Yeah, I think Microsoft.
Yeah, sorry, go ahead.
I think Microsoft came up with this terminology. You can store any data you want in OneLake. It's the storage actually used for Fabric based on my reading last time.
Where to store all of that?
Anything you want.
Absolutely right. We have to store it in a lake. Most of our participants are giving the right response. A lake. A lake is a storage which helps us to store all forms of data at a very cheap rate, at a very high scale. So if I want petabyte scale data to be stored in any format at a very cheap rate, the solution is lake. You have to keep it in a lake. You cannot keep it in mission oriented storages. You cannot keep it in a database. You cannot keep it in a data warehouse. They are mission oriented. They are made for a purpose. They are very expensive as far as storage is concerned. You cannot stuff everything in an Azure SQL database. You cannot stuff everything in SQL Server. You cannot stuff everything in data warehouse. They are purpose built. They are mission oriented. I will deploy a database if I want to do transactions. I would deploy a data warehouse if I want to do analytics. But I am saying I just want to store everything, anything that I can get as an organization. Excel files, anything, as I just told you, videos, sound files, images, right? Anything that can be thought of as a data, backup file, anything. I don't know what I want to do with it. I don't know. It's not mission oriented. I don't have any mission at the moment. I don't want to do transactions, right? I don't want to do analytics. I don't know what I want to do. It's not mission oriented. I just want to store this data. Where to store it? It should be very cheap because my data volume can grow as time progresses. Today I may store 1 GB, but 10 years down the line, petabytes. Exponential data growth may happen. I don't know, right? Today it may be gigabytes. Tomorrow it may be terabytes. 5 years down the line, it would be petabytes. Okay. Exponential data growth, scale. It should scale, right? It should not say, hey, your data size is exhausted. You cannot store more. It should be very cheap. If I want to keep such large volume of data at one place, right? Petabyte scale data at one place, it should be very cheap. It cannot be expensive. If it is expensive, I cannot keep it over there. I would have to figure out some other way, or I would have to basically throw some of the old data, or I would have to archive some of the old data, or we would have to completely delete the old data, right? If it is extremely expensive. So some data which is not mission oriented, we don't know what we want to do with it. It's not purpose built. It's not database. It's not a warehouse, which are purpose built. Databases for transactional needs, warehouses for analytical needs. They are very expensive. Storage is expensive. Query compute is expensive in them. I want cheap object scalable storage where I can stuff everything. And that is a data lake. Data lake also provides us hierarchy. We can create file and folder system. Linux introduced it, right? The Linux kernel and the Unix operating system. They introduced file system, right? You have to create root directory, then you will have directories, then you will have subdirectories, then you will have folders, then you will have subfolders, and then you will have data files. That's called as hierarchical namespace, HNS. Distributed file system it is called as. Earlier we used to have HDFS. Now we have lakes, which are DFS, distributed file systems, because they allow us to create this hierarchy to organize our data. So lake can be deployed in Azure, right? Some people were saying, tell us, why would we do it in Fabric? I can deploy the lake from here. See, this is the lake. I can deploy a lake for you very easily, right? Just few clicks of button, extremely cheap, large scale, 4 petabyte is what in United States they provide us the scale, practically unlimited, right? Lake. I can keep it in the lake. Lake is scalable. Lake is cheap. Lake is essentially democratic. It allows us to store everything, right? So MCT subscription, let me put it inside data engineering, RG. I say enterprise data lake, enterprise data lake. Okay. Maybe someone is already using this name. See, someone in the world is already using this name, enterprise data lake. Someone has created an enterprise data lake using this. So I will just put the name, let us say K21. Okay. Let me deploy it in some region. You can select the data center region according to your data residency, according to your client's data residency. I would simply say central US. Okay. For what purpose you are deploying it? I can say I want to deploy it for data lake storage generation 2. Okay. I say I want to deploy it for data lake generation 2. Okay. ADLS Gen 2 data lake. Okay. Performance is standard, replication local. Let's not go into the details of these settings, right? These settings can be done very easily by the administrators. If you have any questions on these settings, do let me know. I can discuss it offline with you. I will go with the standard general purpose performance, and I will simply say local redundancy. And how to make it a lake? Here is the setting on the next page, which will help me to make it a lake. I can simply say HNS. I say HNS, lake. So if I just select this property HNS, it becomes a lake. It will give me a DFS endpoint, distributed file system endpoint, for any kind of big data processing like Spark or Hadoop or whatever, right? Whatever engine you want to use, that's up to you. So if I were to just simply say review and create for me this lake, because I just enabled hierarchical namespace. What is this hierarchical namespace? Fancy name. It's a fancy name. It's root, directory, subdirectory, folder, subfolder, and file system. That's called as HNS. It's a technical name. Okay. It's just a file system, right? If you have used Unix or Windows, you are already using it, right? So it's just a technical name that they have given it. HNS, hierarchical namespace. Okay. Review and create. That's a lake. Now you tell me, let me put a question to all of our participants. I am creating a lake. If you are a data architect in any organization, you have sales department, you have marketing department, you have IT department, you have HR department, you have so many different departments in your enterprise. They are generating a lot of data in different formats. Sales team is using a complex CRM system like Salesforce. Marketing team is using a complex database like MongoDB. And some other teams are using various other data formats. If you were to be given all of that data, will you keep it in separate lakes, or will you ask someone to integrate it and keep it in one lake? What do you think? What should you do as a data architect?
We keep one lake, and we separate every department with folders. Since this structure is allowing the folders, then we put files for each one of them. We could add more folders inside. To keep it centralized, we have to keep in one data lake. It's better.
Absolutely right. It's common sense. It's common sense. If I were to ask you as a data architect that, would you create silos? Would you disintegrate your data, or you will integrate your data? You will simply say, why would I create disintegrated data as state? Why would I keep the data in different lakes? I would like to integrate it in one place. That's called as data integration. Bringing the data from different data sources like CRM systems, real-time sources, APIs, databases, and bringing it in a single lake. So if I were to ask you a very simple practical question, that if you are the data architect and you have so many departments in your enterprise, sales, marketing, IT, and all of these different departments, and they are generating their data in different formats. Sales department is using a complex CRM system. The marketing team is using a complex database. Your IT department has so many different databases, Cosmos, and so on and so forth, right? If you were to bring the data from them using pipelines, right? We have to write pipelines to bring that data. Would you like to integrate it in one place, or would you like to keep it in many places? Obviously, that's what's called as data integration. I need to integrate, because if I do not integrate, eventually the reports that will be built on those different lakes may have different outputs. The data of the sales team says total sales is $100 million. But the data of the marketing teams, when I use the data of the marketing team to build a report, it says the sales is $110 million. Who is right? What is the total sales? $100 million or $110 million? We don't know. Why? Because we did not integrate the data in one place and remove data inconsistencies. We did not improve data quality. We did not integrate the data and remove these multiple versions of truth. We need one source of truth. So we need OneLake for our entire enterprise. Single lake for our entire enterprise. Fabric. Yes, Fabric. The storage underlying the Fabric is a lake. It's a data storage. It's nothing but a data lake, right? It's a data lake. It comes with a DFS endpoint. So if I were to go for the endpoints, you see, I can just simply show you endpoints. Endpoints. Here you find DFS endpoint, distributed file system endpoint. This is called as a data lake endpoint, right? This is what you use for Spark, right? When you do big data processing, we have to use this URL to read the data and write the data. You will see it when we will do it. It comes with the DFS endpoint. Underneath Fabric, whatever you see, if you create any of these items, here are your items. Look at these items. Any of these items. These are all Fabric items which fall under different workload: engineering workload, factory workload, science workload, warehousing workload, databases workload, industrial solutions, real-time intelligence, and Power BI. These are the workloads. If you create any of these workloads, the data, the metadata, the configuration data of these items are kept in a single OneLake. OneLake is itself a data lake, but it is a single lake for your entire enterprise, where all the internal company data of yours and all the external data from other data sources is kept in a single open data format, and that is Delta format. Structured data in OneLake is kept in an open format. Open format means it's not a proprietary. It's not only for Microsoft, it's not only for AWS, it's not only for Databricks. It's open. Everyone knows it, what that format is. Everyone understands what that format is. It's not a trade secret. It is not proprietary. It is not licensed. It is open. Everyone knows it, what that format is. And that is Delta format. We'll discuss that. Structured data in OneLake is kept in Delta format. Unstructured and semi-structured data can be kept in any format by you. You can keep it in CSV, Excel, PDF, DOCX, any format. Structured data will be kept always in the Delta format, the open Delta Pocket format. Where is OneLake? Can I browse my OneLake? Yes, you can. There is a tool to browse the OneLake. We will look at it later, right? Let me not go into that tool to show you where is the OneLake. But what is OneLake? For your organization, for your company, OneLake is a data lake where all the items that you create in all the different workspaces will be kept over there in workspaces folders. I will show you that, how it is created. Data, the metadata, and the configuration of all of these items in all of these workspaces are kept in OneLake, a unified single data lake for your organization, removing data silos. Yes, removing data silos. There is no separate lake for sales team. There is no separate lake for marketing team. There is no separate lake for data science team. There is no separate lake for data analyst team. There is no separate lake for data governance team. Single lake, one lake for the entire company, which will contain folders of different workspaces, and then the data and the metadata and the configuration of all these items which are under the workspace. OneLake. I will show you how you can browse OneLake and how you can see data. No, OneLake has a storage. You can mirror the data also. You can create shortcuts in OneLake. You can keep the data in OneLake. As we go ahead, you will get answers to all your questions that are popping up. Does OneLake require storage space? Yes, absolutely. How is the real-time data getting synced with the data lake? Is there any latency? See, if there is a real-time data, right, we will process it on the fly. We're not going to store it, right? Yes, output of what you are processing in real time, that will be stored, right? So when we will look at real-time streaming, these questions will be answered. How is the real-time data getting synced with the data lake? Is there any latency? When you're processing a real-time stream, we would not store it in a data lake. It does not remain real-time then, right? If you bring something to rest, it is no longer real-time. Real-time means that we have to process it on the fly as it is moving. As it is generated, we have to capture it and process it. What we get as input and what we produce as the output of processing it on the fly, that we have option to store it. That's optional. But as far as processing is concerned, we have to process it on the fly. If you did not process it on the fly, that's not called real-time processing, right? So we're going to come to that at an appropriate moment, and you will get the answers to these questions also. But I hope you can understand what is OneLake. OneLake is a data lake, but just a single data lake for the entire company, for the entire organization. There will be no separate data lake. There will be no separate data lake for sales. There will be no separate data lakes for marketing. There will be no data movement happening between these lakes. Sales team is asking marketing team, give us the data. So there is a data lake to data lake movement. So duplication of the data is reduced and we don't need to move the data unnecessarily. So we don't need to create unnecessary copies of data. We don't need to move the data unnecessarily. All the different teams, all the different departments, all the project workspaces for our company use a single lake, one lake. I will show you that when we will start demonstrating, right? Okay. So what is OneLake? If I were to just put it in one sentence, technical sentence, OneLake is a data lake, a single data lake for the entire organization. It will keep the data, metadata, configuration data of all the fabric items of all the workspaces of a particular company. If a company creates 1,000 workspaces, within each workspace there are 1,000 items, so there will be 100 million items. Those 100 million items would be sitting in the one lake of the company, single lake. Why do you want a single lake? I don't want to duplicate the data between different departments. I don't want those different departments to fight on the single version of truth. I want integration of the data in one lake. I can create shortcuts in one lake. I can keep the data in one lake. I can mirror the data in one lake. That all we will see as we go ahead, right? But one lake is a single lake for the entire organization. It removes data silos and it integrates our data estate, removing the need for too much of data copy, data duplication, and too much of unnecessary data pipelining and data movements. One lake. But as I told you, structured data in one lake is kept in Delta format. Yes, which is an open format. Everyone knows about it. So when you combine unstructured data in any format and structured data in Delta format, that is called as a lake house. We have given it a technical name. What is the technical name? The technical name is lake house. What is that? Unstructured data in any format, CSV, Excel, Parquet, backup file, WV file, MP3 file, MP4 file, video file, PDF file, any file, unstructured, no problem. GIF, JPG, any format, no problem at all. But structured data, tabular data in Delta format, open Delta format. If you keep the data in this way, that's called as a lake plus a house, because the Delta format is structured, because the Parquet files are used to manage the data, and Parquet files are columnar for analytical needs. Right? Let me create new workspace first of all. So workspace means a project workspace in which I want to do a project and keep all the items of that project. So I say I want a new workspace. I say fabric class 1 workspace. Make sure that if you want to use fabric, you keep it on trial or premium capacity or fabric capacity. These two are paid features. Fabric capacity paid, premium capacity is also paid. So let's not worry on that front. When you will work in a real project in your company, they might be using premium capacity or a fabric capacity because they would be paying it to Microsoft. Right now, we are just doing a trial. So I want to say trial, right? That's it. Don't worry about other settings. I will highlight what other settings are, like semantic model storage format. If you want your semantic models to grow beyond 10 gigabytes in size, you will go with large semantic model storage format. Currently, we are not going to build any data model which will be higher than 10 gigabytes. So don't worry on this front. No template apps we will be developing, right? So we simply say apply a workspace. Give me a workspace. Here it is. Project workspace. Okay. Here is the project workspace, and let me collapse the task flows. Here it is. Fabric class 01 workspace. And you see this item, this means fabric enabled premium. This is fabric enabled premium content that you can see. And this is trial workspace. You are trying out fabric so that you can eventually purchase and eventually use it in your enterprise wide projects for your clients and customers. Let me say I want a new item in this workspace. They say, okay, which item do you want? Another way would be, see here they are not putting it, here they are putting it in terms of task, get data, store data, prepare data, analyze and train data, track data. This is task. Organizing them is called as task flow. task flow. We will come to task flow a little later. Don't confuse yourself, right? But see, if I say new item, it organizes for you it in terms of tasks, get data task, store data task. So what do we want to do at this moment? Store data, lakehouse. So what are the three tools to which you can connect your lakehouse via its SQL analytics endpoint? The three tools which we can connect to via the SQL analytics endpoint is SQL Server Management Studio, Data Studio, and Power BI for obvious reasons. Okay, SSMS for SQL exploration, for exploration using structured query language, to the Data Studio for collaboration. I and my colleague are peer programmers, right? Peer programming. I and my colleague are writing data exploration in SQL. Okay, that we will do in Data Studio. And in Power BI, a data analyst will do sophisticated modeling using the delta tables and the views of the delta tables. I just had one table for you and did a very simple report for you, right? It could be very complex. If I tell you all of this you can do inside Fabric, would you like to open those tools? If I were to tell you these delta tables, you can directly query them using structured query language, no need to open SSMS, no need to open Data Studio. Yes, if you want to open Data Studio, fine, right? But there is no such need, mandatory. You can do it in Fabric. What you did in Power BI, you can do it here itself. Would you be happy or sad? You will be happy. You're making my life easy, right? Absolutely, yes. On these delta files and the views of these delta files, I can do reporting. So see, I will change from Lakehouse exploration to SQL Analytics endpoint. It is like I am connecting to Data Studio. I am connecting to SSMS. Open this SQL Analytics endpoint. Open this. It is like connecting to Azure Data Studio or connecting to SSMS. See, here we are. Here is our delta table. Real table, not an external table. It's not a fake table at all. It's not a poorly performing external table. It's not a poorly performing external table at all. Okay, the real table. Now I am in a SQL Analytics endpoint, read only SQL Analytics endpoint. Why it is read only? Obviously, they cannot allow transaction through this endpoint. Otherwise, it will not get recorded in the delta log. At the end of the day, it is a delta table with delta log in it, right? So here you see the table is there. Same reporting query I can do here. New SQL query in a notebook. Can you understand what this is? This is a standalone query. This is for collaboration with your colleague, peer programmer. There is no need to open Data Studio, okay? You can do it from here itself. I say I want to write a standalone query. What is a standalone query? Again, the same thing. Monthly, I want a monthly select month part of the order date as month, count the primary key of this table, which is sales order number, as total orders from this table, which is dbo dot sales group by group by month of the order date, order by the month, ascending. Here it is, monthly sales report. You can download the entire content in an Excel file if you want to keep it in Excel file. And if you want to explore this, right, you can select this without order by clause. Don't select the order by. Order by is not supported in exploration. Just select everything except order by, right? And say I want to explore it graphically and save this business view for business consumer. Report consumer. Data exploration made easy. There is no need for you to connect into Power BI, then load it into Power Query, and then load it into the model, and then draw a visualization. Direct. Simply say I want to visualize it. What do you want to visualize? Month and total orders. Sum of month? No. Don't summarize it. Don't summarize. Now, month, this is a sales graph. This is the sales graph. Wonderful, wonderful, wonderful. There's a sales graph for this thing, right? I hope you can see. Sales graph, monthly sales graph, sum of total orders and month. So it is increasing after the, looks like June, and then it increased. I can save it as a report or save it as an exploration. I can say I want to save it as an exploration for others so that they don't do the same exploration, right? Why would I ask them to do the same exploration, right? So I say monthly sales, exploration, exploration item, right? Exploration item, save it to this exploration item. So you now find all of a sudden that what I would have to do in two different tools, I would have to open Data Studio and then Power BI to do all of this, isn't it? Right or wrong? I would have to open Data Studio, or I would have to open SSMS because I want to query using SQL. And then I would have to do Power BI because I have to do exploration. No need. Simply go to your lake house, go to its SQL Analytics endpoint. From the exploration, turn to SQL Analytics endpoint, run a query from here itself on your Delta table, and visualize it from here. Save the exploration for others to consume. We saved it as an exploration. Here is the exploration. Someone has already done it. I did it. Others can now consume it. They don't have to do it again. Monthly sales exploration. Other thing I could do is I could go back to my lake house, SQL Analytics endpoint of my lake house. Another thing I could do is I could save it as a view so that others can build a report on this. I don't want to build them a report. They can build the report. Monthly sales view. You know, view will automatically update if the underlying Delta table changes its data. Right or wrong, right? View will automatically update itself if the underlying table data changes. You might say you are creating a view, right? Absolutely, yes. It's a DDL statement, not a DML statement. This does not go into the Delta log. Okay. So here we go. We say this is the data definition language, and I say monthly sales view. Okay. We have 15 more minutes remaining. So now you observe the view is created. Now, what will be the benefit of the view? This view will allow people to develop reports themselves. Yes, we can do functions and stored procedures as well, server-side programming, but that would be little advanced. Let's not go into that at this moment. Let me not overcomplicate. Right now, we can do functions and stored procs also. Server-side programming also we can do. But you see, view. I created a view, monthly sales view. So if someone wants to build a report on this view itself, they can build the report on this view itself. They can build a report on this view itself. They don't need to run this query again. They can do it from the view because I did the work for them as a view. Right? Just 15 more minutes are remaining. Just give me 15 more minutes. We are almost done. Right? So you can do SQL queries just like this. Visualize them. Save your explorations like this. See, I just saved the exploration. Oops. Here is the exploration. I hope clear. Run the query, save the exploration. There is no need for you to open Data Studio and then open Power BI and then do the visualization. There is no such need, essentially. No such need. You don't need to do that. You can do it in one go. Just go to your SQL Analytics endpoint and then simply run the SQL query and visualize it. Alternatively, SQL query to the view so that others can now build the report on this. How will they build the report on this? How can they build the report on this? They have to simply go to the default semantic endpoint. See how simple it is, right? How seamless it is. I don't need to open anything. I need to go to default semantic model. I just click on this if I want to build a report. No need for me to open the Power BI. I can simply go to this endpoint and I can do a report, auto create a report. I don't even need to create a new report. I can auto create a report. Oh, cannot load the model. Okay, just a second. Sometime it can happen. Okay. Go back. Just give me a second. No problem. Remove the report. Workspace. Go to the lake house. Go to its new semantic model. We already have a semantic model. I don't want a new one. SQL Analytics endpoint. And you see, we'll get a reporting option from here. Reporting. You say model layout. Default semantic model will automatically come under model layout. Okay, so click on model layout. The view and the sales table will be automatically visible under the model layout, default semantic model. Okay, see, these are some performance tables. Don't worry on that. Here are our tables: monthly sales and sales. Don't worry on these tables, right? Don't please worry on these tables. These are performance tables. Okay, they are a part of performance tuning. When you will become expert in Fabric, they will ask you to tune the queries on the default semantic model. Here are the two tables. One is a table, another is a view. I can do a report on them. Reporting, new report. There is no need for me to open Power BI. There is no need for me to develop a semantic model. They're saying default semantic model. All your delta tables, all your views of the delta tables are automatically added to this default semantic model. You don't need to do anything. Default semantic model is already there. Your views and your delta tables are under it. You can go and you can now report on them. So I say, okay, give me that tables, please. One table, one view. No need for me to open Power BI, anything like that. This is using default semantic model. And now I can do the same pie chart. Okay, give me monthly sales. Okay, I can do a line chart for you. Month, total orders, yeah. This is the sales growth that these people are observing. Simple, very simple chart. Not overcomplicating the issue. But can you see how Fabric made it seamless? Oh, I don't need to open SSMS. I don't need to open Data Studio. I don't even need to develop a semantic model. You are giving me something which is called as a default semantic model. I can save this report, save the report. Okay, give name to your report, total monthly sales report. Okay, simple report saved. So here you see exploration and a report. And did I do any semantic modeling? No, the lake house, whatever the tables and the views that I have in my lake house, go to the SQL Analytics endpoint. Whatever the delta tables and the views that I have under my lake house, they are automatically added to the default semantic endpoint, default Power BI semantic model. They are added automatically inside this body. I have to just consume it as it is. I have to just go and say, go back to the SQL endpoint, see SQL Analytics endpoint, and simply say model layout and reporting. Reporting using new report. I can develop a new semantic model if I wish. I can manage the default semantic model. I can automatically update the semantic model. I will show you what these are a little later. But can you see this, right? That we can very easily go and create a view, go and create an exploration, go and create a report by consuming the default semantic model. Fabric helps us save time. Fabric helps us make us more efficient. Now, you might be wondering that it will take time for us to digest all of this. Absolutely. It will take you a lot of time to digest all of this. Practice would be extremely. No, default semantic model is not updatable. You cannot delete objects from the default semantic model. For that, you're going to have to create a new model, or you have to go to the settings of the default semantic model. See this, you will have to go to the settings of the default semantic model and tell the default semantic model that don't synchronize with my tables and objects. I will manually put the table, sync the default Power BI semantic model. Currently it is on. I can turn it off. You will have to now manually add the objects. Yeah, it is best. Nas, you are right. We should manually add, but they want to make your life easy, right? Things will be automatically added to the default semantic model. If you really want something to do customized, you can turn that on over there, or you can simply go to the SQL Analytics endpoint and create your own semantic model. New one. Which table do you want? Select that only. Okay, all tables, or you only want this table, right? You say, okay, that's it. Okay. Give your semantic model a name, new semantic model with my own selected views and table, with my own selected views and tables. I don't want default one. I will create my own. Later, we will create our own because we will set up relationships, right? We will create our own because we're going to set up relationships later. Amazing. How seamlessly it is helping me to flow. I don't need to switch to multiple services. I don't need to deploy a separate lake. I don't need to create a synapse. I don't need those external fake tables. All my Delta tables are real Delta tables. They have real data and in an open data format. That is Delta. Everyone understands that format. No one would tell me, hey, this is proprietary. Only Microsoft can handle this. Something, if it is proprietary, it is restrictive, right? Because it is tied to a single vendor. Only Microsoft knows that format. No one else knows in the world what that is. But Delta Pocket is an open format, right? Twitter and Databricks in collaboration created it, the Delta Pocket format for analytical needs. Okay. So you see that we can very easily work with the lake houses.
Thank you for watching this video. Now, all you need to do is click the link in the description below, or if you're just starting out, type k21academy.com/dp702 into your browser. Once you're on the page, enter your name, email ID, and your phone number. Then click on register now. Now, here you will be redirected to a thank you page where you can easily add the session to your Google or Apple Calendar. This is your chance to gain valuable insights, so don't miss out. Click the link now and take your learning to the next level. See you in the session.